everyone, welcome to Bright Future YouTube channel. My name is NomsaMashaba and I'll be introducing you to organic chemistry. I will try to make this chapter exciting because a lot of students are struggling with organic chemistry. Take a look at the following.
A few moments later.
Organic chemistry is not the favorite of students, but I know why. Organic chemistry have a lot of terminology that you need to know. Memorizing won't help you to pass this subject, but practicing and putting more time in it will surely help you pass this subject. So let's get started. Okay guys, what is organic chemistry? The word organic stands for molecules that consist of carbon. It's all about carbon. Carbon is the backbone of organic chemistry. Carbon has this amazing ability if you recall from grade 10 and 11. But if you don't recall, that's fine. Carbon has 4 valence electrons, meaning it has 4 electrons on its outside electron shell, meaning it can form 4 bonds with surrounding molecules. Let's take a look at the following example. Okay guys, in this example, we have a carbon which is attached to a hydrogen and another hydrogen and another hydrogen, and also is attached to a carbon. So this carbon will repeat the process and eventually you will end up with that long chain having thousands of carbons. And that's the primary phenomenon that we'll keep seeing in organic chemistry. These long chains made up of carbons, and then it's also going to have another atom attached to it, such as hydrogen. Okay, we have already attached an hydrogen to our carbons, and that's the most common one. And another one is oxygen. A lot of haloalkanes, which are fluorine, chlorine, and bromine, things like that. So let's finish up drawing our structural molecule. So let's say here we have a halogen. Maybe it's a chlorine and here maybe a hydrogen. Okay guys, that's what we will be seeing together with carbons. So these atoms are going to combine with carbon to form various types of combinations. So we are going to study 9 various combinations today. The first one. Okay guys, the first combination that we'll be talking about today is alkanes. Alkanes consist of carbons and hydrogens only, and they have single bonds. As you can see from our picture there, we have 3 carbons and 8 hydrogens. So yeah, that's our alkane. And the second combination that we'll be learning about today is alkenes. Alkenes are almost the same as alkanes, however they have double bond. That's why we can see two lines next to the first and the second carbon. In fact, between those two carbons. Yeah. Next, we'll be looking at the alkynes, which have a triple bond. That's why you can see three lines in between the first two carbons. In our picture there. So yeah, that's our alkynes. Next, we have haloalkanes. Now, the name tells us everything. The halo stands for halogens, which are in group 7 in our periodic table, such as chlorine, fluorine, bromine, and iodide. And then alkanes are our single bonds, hydrocarbons. So here we have single bonds everywhere and a halogen which is attached to our second carbon. Moving on to alcohols. Now what makes the alcohol unique is that they have an OH bond while the rest of the chain is alkanes. So as you can see on our last carbon, is attached to an OH bond, so that makes it our alcohol. Next we have aldehydes. What makes aldehydes unique is that they have a carbon at the end that is attached to a double bond oxygen and one hydrogen on the side. Yeah guys, as you can see in our picture, the last carbon is attached to a double bond oxygen and hydrogen on the side. Next we have ketones. What makes ketones unique is that they have a carbon attached to a double bond oxygen, just like we saw with the aldehydes. But what makes them different from the aldehydes is that the carbon that is attached to a double bond oxygen is also attached to two carbons on both the right and the left side. So yeah, as you can see in our picture. Next, we have carboxylic acids. What makes carboxylic acids unique is that they consist of a carbon that is attached to a double bond oxygen, just like we saw with ketones and aldehydes. However, on that carbon, we have OH bond, which is the alcohol. As you can see in our picture, our last carbon is attached to a double bond oxygen and an OH bond next to it. Last one, we have esters. And what makes them unique is that they are the only ones that have a random oxygen atom in between two carbons. If you look at the others, it's just carbons the whole time. Okay guys, that's it for today's video. I hope you understood. If you haven't understood, as usual, please leave a comment under the comment section below. Thank you so much for tuning in. Until we meet again next time, guys, please don't forget to subscribe, like, share, and comment the video. Thank you guys. Stay blessed.